Hello and welcome back today, everybody. Let's see. First thing, my wife suggested that maybe I should give extra credit to the first person who can answer this question. So earlier in the year, well, we've done a lot of talking during the course of the year, but there's one hobby that I have that I said, don't judge me on the hobby. And I thought it was one of the coolest hobbies of all times. All right. So if you can let me know what that hobby is, then again, you'll get some extra credit for that. All right. So what was the hobby that I said don't judge me on until you've actually tried this? Okay. So let me get my pen going today. And today I want to talk about absolute max and min points. So these aren't the local ones like yesterday, but the local ones, a lot of times end up being the absolute also. So I thought we would start by taking a look at the same picture that I had yesterday. Um, so let's see, I called this P of X. Let's say that this is a profit formula. So you're working for a company, and what you find during the course of the year is the profits go up, they come down a little bit, they go up, they come down, and maybe the X stands for the number of items that you're making. You could be making some commodity. You could be making washing machines. You can be making donuts. It really doesn't matter. As a business, you would want to make sure that you can have the highest profit. So if my highest profit ends up being at 20,000 donuts, why would you make any more? If you know that the amount of profit, the amount of money you're bringing in is going to go down from that, right? You would want to stop at that point. So anybody's going to go in the business world, this is where you would end up using calculus. In fact, if you're going into business, a lot of colleges are going to tell you to take a business calculus class. And what they'll do is they'll show you how to do calculus, just like a math calculus, an engineering calculus, an economics calculus. But the difference is you would look at problems that you would use in the business world, where somebody and an economist would look more at the economic side to it, or an engineer would look at the engineer side to it. Or if you're on the math side, all right, if you take math calculus, which is what most colleges offer, then you would just look at a bunch of generic different types of examples from all the different fields. Other things to think about here. Now, this is a continuous graph, at least the way it's drawn, but we know in the real world, sometimes it doesn't make any sense to go below the x-axis. Sometimes it doesn't make any sense to have negative x values, especially if you're talking like time, or if you're even talking about a commodity. You're not going to be making minus 1,000 donuts, all right? It would start at zero and then would have to go up from there. So sometimes the equations don't put that domain in there. You have to think about the domain. Sometimes you're given the domains, all right? That can all vary. Now, here's what I want you to think about. Let me erase this. Let's take this graph here, and let's say the graph actually started here, and it went up, came down, went up. I didn't draw that very good. And let's say it stopped right there. Let me see if I can put a circle. We're going to pretend that's closed in. And if I was looking for a max or min point, I can see my absolute max point is up there. I can see the absolute min point is down here. What's true at the max point? Well, I know the slope is zero. Actually, we know the slope is zero at there and there and there. We saw that yesterday. All right. So all 3 points where the slope equals zero are potentially the absolute maximum and minimum points. The absolute min point actually wasn't down here, though. That just ends up being local. My absolute min point is right here at my endpoint where the graph has started. So when I'm looking for absolute max and mins, there are two different types of values that you need to look for. You do need to look for when the slope is equal to zero, like we did yesterday. But then you got to look at the endpoints also. Now, remember, sometimes you're given endpoints, sometimes you're not given endpoints. All right. It might be that a graph goes on forever, all right, in one direction or both directions. Or it might be that in the problem, you have to go looking for it. If you're looking for the maximum amount of sunlight at any time during the day, the day only goes up to 24 hours and then we start up again. So even though you might not be told that, look for the next 24 hours, you have to interpret into that. Here are the steps that we take in order to find the absolute max and min. Now, I'm going to keep talking again, but again, you might want to pause this in order to write everything down. To find the absolute max or min values, this is not local, but absolute, you still want to start by finding the x values when the slope is equal to 0. You would still need the derivative and set it equal to 0. You then need to find the endpoints, if there are any. Now, today, I'm going to pretty much give you the endpoints. I'm going to give you intervals, all right? But in a lot of the word problems that you would see, you would not be given the endpoints, and you have to determine them if there are any. And here's what we're going to change from yesterday. The difference now is once you have all these values where the slope is equal to 0, and you have your two endpoints, you take each of those x values and you plug it into the original equation, because you want to see what is the largest y value and what is the smallest y value. So we're not looking locally. We don't care what happens to either side. We just want to know what is the maximum point and the minimum point. It's got to occur at when a slope is equal to 0 or at the endpoints. It's got to be at one of those two options. So let's try this. Directions. Find the absolute max or min points on the following equation. On the interval going from -3 to 2. So I'm telling you, I only want this graph. We're only looking at the graph in between -3 and 2. Now, if you have the graphing calculator, this is quite simple, because you can change your window from -3 to 2, and I would advise checking your final answers on every problem that I have you do. But this is really meant for a non-calculator. Step 1, find our derivative, set it equal to 0, and find out when the slope would be equal to 0. So step 1 is find out when the slope is equal to 0. Now, if you notice, this is the same first equation that we started with yesterday. The derivative is the same. And you might have forgot, but we ended up with x equals a +1 and a -1. All right, so there's the first points we need from step 1. Step 2, make sure you have your endpoints. Your endpoints are at -3 and +2. All right, so they're given to you. You're told only look at this graph from -3 to +2. That's where I want to find my highest points and my lowest points. Step 3, and I'm going to change the colors on you here, is plug each of these points, we have 4 points total here, into the original function. That original function is g. I need to know g of 1. I need to know g of -1. I need to know g of the endpoint of -3. And I need to know the g point of the endpoint of +2. Now, without a calculator, sometimes it takes a little longer. With the calculator, this is usually pretty quick. If you plug g of 1 into the equation, you can get 0 back. Remember, you're not plugging it into the slope. We're not checking the slope here, all right? But the actual y value. G of -1 will give you 4 back. If you plug g of -3 in, you get -16. And if you plug 2 into the original equation, you come back with 4. So when x equals 1, you're at the point 0, right? That is the point 1, 0, if you think about it. At -1, you're at the point 4. At -3, you're at -16. And at 2, you were at 4. So the question says, what are the absolute max and min points here? I thought I had some space here. All right, let me go erase some things. I don't need this stuff anymore. I don't need the derivative anymore. Okay, so the absolute max points. Now, if you notice, there are two of them here, right? And that's fine. At -1, 4 was the y, and at +2, the endpoint, we also hit 4. So there's actually twice in this interval that we hit the highest point. And the absolute min, it occurred only once, and that was down here when x is equal to -3. We're going to hit the 16. -16, excuse me. Right? So just like yesterday, there are times where they will say, hey, what x value gives you the absolute max? There'll be times it will say, what is the y value that gives me the absolute max or min? And there are going to be times where you want the entire point. And your job is to pay attention to that. The x value tends to be like time or the amount of things that you're making. The y value tends to be things like money or area, all right? And that's usually what we're looking for. What's the most amount of profit that we can make, right? And the y value, again, is what would be measuring that. Okay. Let's go to our second problem. Again, notice we did this one yesterday, all right? Only yesterday we were just looking for the local points. All right, I want the absolute points. I need to know my derivative. I want you to take a few seconds here and come up with your derivative. Set that derivative equal to 0. All right, this should look familiar since it was in that last lesson. We got x equals 0 and x equals 1. Okay, slope is equal to 0 at x equals 0 and x equals 1. All right, that's our first step. Second step is make sure you know the endpoints. The endpoints are -1 and 2. I don't need that. All right. Third step is to plug these all into the original equation. Now, before you do that, I do want to point out up here, when you figured out the slope was 0 at x equals 0 and x equals 1, those points don't have to be within this interval here. In fact, if we would have come up with a third point, let's say we found out that at x equals 5, the slope was 0, you can go back and you can reject that because it's not within 0 and 2. All right, so just because you find out the slope equals 0, it might not be within the interval that you're looking at, all right? And you just ignore those, all right? You're only looking at numbers in between, in this case, -1 and 2. Okay, so I'm going to need some space here, so I'm going to get rid of this. We needed to look at x equals 0, 1, -1, and 2. So here's where we take all of these and we plug it into our equation y. And why am I putting g there? Y equals 2. All right, so I'm going to trust that you can do most of the arithmetic correct. All right, I know we do make some mistakes. If you plug 0 into the original function, you'll get a 5 back. That means the point 0.05 is a point on the graph. If you plug 1 in there, you'll get a 6 back. If you plug -1 in, you get 14 back. And if you plug 2 in there, you are going to get, not y equals 2, y of 2, you can get -43. Okay, so absolute max is where? The point -1, 14 was the highest. As it turns out, it ends up being right at the endpoint. Our absolute minimum point ends up being at the other endpoint. It's at 2, -43. Right? And there's no way we would have got that if we didn't know the endpoints of that interval. If this was a graph that went on forever, this is an x to the 5th. If you remember from yesterday, we said therefore change the direction. There is no absolute max or min. But as soon as you cut off the graph at some endpoints, now we do have a highest spot and a lowest spot. All right. Think about the differences between absolute and local. All right. I thought we could finish by taking a look at a word problem. Now, sometimes you have to develop an equation yourself. Sometimes they are given to you. In this case, I've given it to you. If you're working for a business, you might have to, crunch the numbers from the business and come up with an equation like this. This says the profit of a candy company making X tons of candy. So X isn't like each individual candy bar, but it's measured by tons. All right. X tons of candy is given by the following equation. How many tons of candy should this company produce in order to maximize the profit? And what is that profit? How many tons of candy should they produce? So the first question is asking for the X value. What X value would be the max here? And in the second one, what is that profit? Well, that's our Y value, or even better, that's our P of X. All right, since that's what the equation was. P of X is measuring the profit. Okay, now it doesn't say the absolute, but the max, but this is clearly an absolute max problem. All right, I don't care locally. We want to know how much can we make overall. So I'm going to take my derivative. Derivative of -4,000 is 0. Derivative of 204x is 204. And the derivative of 0.17x squared is 0.34x. I'm going to set it equal to 0. I'm going to solve. And I got x equals 600. Now, I don't know for sure if that is the max, all right? A couple things I could do. If I'm looking for the absolute, we're supposed to check the endpoints also, all right? What would the endpoints be for this? So ask yourself, what is the least amount of candy you can make? Well, that'd be x equals 0. We could say that we're not going to make anything. What would be the most amount of candy you can make? Well, there actually is not a limit here, right? We could keep going on forever, right? And so I can't use infinity in this. So I really only have one endpoint to check. Now we're going to take my one endpoint that we do have, and when the slope equals 0, which is at 600, and we're going to plug them into the original equation, the one that was given in the graph, because we want to know which one is the maximum profit. So we want the profit at 600, and we want to know what's the profit at 0. Now, you would definitely have a calculator on this problem, all right? So to save you a little time, if you plug in 600, you would come back with 57,200. If you plug 0 in there, that's a little easier. You get negative 4,000, right? So my profit, right, my maximum profit occurred at 600 tons. And how much money would be that maximum profit? It would be 57,200. Now we can see from the one endpoint that we did have, if you decide to make no candy, you're actually going to lose 4,000. So that would be like $4,000 that you maybe have spent in materials or machines, overhead, whatever the case might be. All right, you got started, but then you kind of quit along the way. You can kind of take a look at both sides of the 600 also. Take a number greater, 620. Take a number less, 598. Plug them both into the profit formula, and you're going to see that you do have a number that's less than this. The other thing to think about is the graph. So let me come back here for a minute, and I'm just going to erase this. If you think about this graph here, the graph looks like this. All right, here's my X, here's my profit. We're looking for this up here, the maximum profit, right? It should make sense that there's only one point where the slope is equal to 0 because it's a quadratic. If you used our derivative formula or our vertex formula, X equals negative B over twice A. All right, we talked a little bit about that yesterday, that it came from calculus. Notice you still get the 600. Everything should make sense with that. If you would put 600 on a wiggle graph, P prime, now remember the wiggle graph checks the slope. You would have plugged in a number before 600, like 0, right? You would have got a positive back. And you could check a number greater than 600 and, maybe 10, maybe 1,000, right? And you would have got a negative back, and you could have seen you went from positive to negative. Now that defends that it's a local, but because you only had one time where the graph changed directions, that means it would also have to be an absolute. Okay. Absolute maximins, also not that difficult. In fact, a lot of people find them to be a little easier than the local. I really find them to be pretty close to each other. So what we want to think about here when we are deciding between the absolute max or min or the local max or min, the steps were a little different. Number one, you need to find a derivative, set it equal to 0. It doesn't matter which one of these you had. That's where you're going to start. All max and mins are when the slope is 0 or the slope is undefined. And as I mentioned yesterday, we're not doing the slope is undefined yet. Second step. Well, for the local max or min, we said put this on a wiggle graph. All right. All right, let's try that again. Wiggle graph, which is just a number line where you're checking slopes going from minus to plus or plus to minus. For the absolute, we said you're also going to need to know the endpoints, if there are any. Right? A lot of times 0 ends up being an endpoint. If you're following the path of a ball that's bouncing, hey, at some point it's going to hit the ground and it's going to stop. All right, and that would be an endpoint you'd have to find. And then the last thing here is you got to plug all of those back into the original function, right, and see which one is the largest and figure out which one is the smallest for that max or min. Right, very close to one another. The test for them to find them really ends up being different in that last step. Okay, good luck. You got problems that are all on a worksheet today. And again, I don't think you're going to be overwhelmed with them. I'll talk to you again real soon, and somebody come up with the answer to that trivia question for me.